Respected delegates, ladies and gentlemen, I would like to present my paper on influence of wall envelope material on cooling load estimate in warm humid climate. As you know, buildings are supposed to give indoor environment which are comfortable for the occupants. The thermal comfort of occupants is in fact their well-being, where they are in a thermal equilibrium physiologically as well as psychologically. This can be normally achieved if we do the design of the building by looking at the climate of the place where the building is built. So it actually takes into account the way the building envelope is designed. Rather, the building envelope is the one which decides the comfort conditions indoors. Almost like the global scene, the electricity consumption in India, if you look at, almost 33% of the consumption is by the building sector, where 24% of that is consumed by the residential sector. It is estimated that if the current trend goes, by the year 2040, the consumption of the residential sector of the electricity energy will be almost doubled. And that has been projected by many agencies across. Now, if you look at the details of the energy consumption, the electricity consumption, it is quite clear that among the various uses, the indoor heating and cooling, when it comes to the temperate climate, it is basically the cooling requirement which takes a large share of this electric energy. It was seen that 3.5 million units of room air conditioners were sold in the 2010-11 year in India, and it is estimated that this will increase by 10% through 2020. And if you look at the components of this consumption as given by the Energy Conservation Building Code, which is now being generally taken into account in the building design in India, which is actually put forward by the the BEE. It takes building envelope. It's taken building envelope. It's by the comfort systems for indoor environment, basically the fans and air conditioners, lighting, and other power consumption. When it comes to the envelope, the building envelope, ECBC says that if you make the building envelope conducive to the environment, or rather, if you decide the material by which this building envelope is constructed, there can be a saving of almost 60% of the energy which is now being utilized in giving the indoor comfort conditions. 15 to 20% reduction in the uncomfortable hours can be achieved only by increasing the efficiency, energy efficiency of the building envelope, or rather, it's the envelope efficiency of the naturally ventilated buildings. When it comes to the tropical climate, and that too when we talk about the warm, humid climate, it's important that we need to have a lot of air exchange, and that too with natural ventilation. So it's important that we go for an envelope which is designed for such an environment, which makes the indoor comfortable and energy efficient. Now coming to the study area, we have conducted a study in Kerala, where we belong to. As you know, this is the southernmost part of India, where we have a warm, humid climate, where it is characterized by the high rainfall with high humidity, which is even quite high in the summer months, with its characteristic feature of very less diurnal variations. And it is seen that almost 51% of the electricity is consumed in Kerala, which is by the residential sector. And if you look at this graph, it says that the energy consumption of electricity is at the peak during the summer months. It goes high during the summer months, right from January, and then it peaks in April and May. And then as this monsoon sets in, that is the rainy season comes in the month of June, okay, it comes to the lowest level. Now, if you look at the local construction, the residential buildings are mostly made of masonry, and out of that, it is a stone wall which takes a larger share. There are materials like concrete blocks, burnt bricks, and other masonry blocks which are in use. So the objective of our study was basically to understand the thermal behavior of masonry envelope through a real-time field study. So we have conducted basically field studies to understand the comfort conditions and the behavior of this envelope made of masonry materials, and to compare the thermal performance of these masonry envelopes based on the dynamic thermal performance indicators, and also to know the influence of this wall envelopes on the cooling load, which is obviously connected to the heat gain through the wall envelope. The methodology of study goes like this. We have done the selection of the buildings which are supposed to be studied, and then we did the experimental setup which was running real time in those building sites for a few days. The parameters which were required to be monitored were recorded. The thermal performance indicators were then looked into, and also we did certain theoretical calculations to understand the behavior of this building envelope. And then we concluded the study with the heat gain calculations, which gives us the cooling load estimate. If we look at the details, the studies were basically conducted, as you know, in Kerala, and then we have taken one district of Kerala, and that is where our institute belongs to, which is the district of Kozhikode. And we have conducted the study in buildings where the building envelope, that is the walls, were made of the most commonly used materials. So we have take into account the clay bricks, concrete masonry units, laterite stones, and handmade mud blocks for the study purpose. And since the walls are the study part of the building or the envelope, which is actually exposed to the sun during the early period of the year, that is from January to say April or May, we have taken the southern walls which are exposed to the solar radiation during these summer months. As you know, the real-time measures were taken with the help of a custom-made instrumental setup called architectural evaluation system, which is nothing but a data synthesizer which can record the data which are given from the sensors, and we had used a wireless system. So the sensors were basically sending the data to the data logger with a wireless system. So we had a set of electronic sensors which were acquiring the data from different locations, and of course this has a software which makes it feasible for getting the data uploaded to a server, cloud-based server, and then getting it downloaded into the system at any point of time. And the parameters which we used to look into the comfort conditions are listed here. So in the indoors, we looked at the indoor temperature, we looked at the indoor relative humidity as well as group temperature. And outdoor, obviously we looked at the outdoor air temperature, relative humidity, and the solar radiation. Whereas on the surface, that is the envelope part, we looked at the surface temperature outside the wall as well as the surface temperature inside. So the sensors were actually installed at all these places. In fact, they were stuck onto the surfaces where we were intended to get the readings of the surface temperature, and the others were kept in the ambient condition. The period of study was from Feb to April of 2019. Now, to look into the comfort part, okay, we took into account the time lag and determinant factor, which are the two parameters used as the indicators of thermal performance when it comes to the building envelope components. These two indicators are used to understand the effect of heat storage and dissipation capacity of the component. So as you know, the determinant factor is defined as a ratio of the difference between the surface temperature inside max and same, okay, when it comes to minimum, and over the surface temperature which is outside, okay, the maximum and minimum value. Time lag is nothing but the difference between the peaks of the indoor as well as the outdoor. And this gives you an understanding of the way that the solar radiation were there on the walls. So more or less we had a constant kind of a solar radiation received on the walls which were studied, though there were some variation, okay, right, from 700 to 900 odd watts per meter square. Now to look into the results, okay, these are the four cases which were studied, and all these were plotted for a day, that is for 24 hours, right from morning till evening, morning till the next day morning. And in all these you find that the outside surface temperature is the one which is having the maximum value, okay, varying from morning, okay, and it peaks in the mid-noon and then goes to the evening, and then it comes down during the night. The outdoor ambient temperature was the one which was next to it, and we had this inside surface temperature which was Okay, again, low in the beginning and then it goes higher, okay, during the evening hours, because the heat need to be transmitted from the out to the indoors. But the variations were quite less. And then also we looked at in the indoor air temperature. So the amplitude is greatly reduced in the indoor temperature distributions, as you know. You look at the variations. And outdoor ambient temperature and outside surface temperature falls below the indoor air temperature and inside surface temperature during the late evenings. So if you look at this part of the graph, you find, okay, these two curves are actually going under the outdoor conditions. And this is in a different way, the same thing is represented. So outdoor conditions are depicted on this side of the wall, and then this is the indoor. So we can know this is how the variation happens outside, whereas, okay, a narrow range of the same thing is happening inside. Okay, and this is for okay, the wall with brick, and this is with the wall of concrete. Okay, the variation is very narrow, and laterite wall gives you, okay, much more narrow, and then you have the mud wall, which is somewhere in between. Now, if you look at the theoretical values computed, as well as the other two parameters which we have taken into account, the R value and U value, if you look at, that is how normally we do the comparison. So the brick value, R value, is the highest among all the four, with the least, which was for the concrete block. So naturally, the U value was highest for concrete and it was least for brick. But then, if you look at the decrement factor and time lag, okay, it's very interesting to note that in the case of the stone, laterite stone, okay, that was giving the least decrement factor and it was giving the maximum time lag. So these two together gives the advantage when it comes to the thermal insulation. Resistance value alone cannot be considered as an indicator of the dynamic thermal performance of wall. So the decrement factor and time lag does not solely depend on these two parameters. If you look at the cooling load, or rather the heat gain calculations, okay, this is the pie chart which is giving you the heat gain. So if you look at the building, okay, we have taken a building of 3 by 3 by 3 with a pitched roof for the calculation. So if you look at this, other than the exposed window, okay, it was the roof which was taken the largest share, and then the wall. And if you look at the heat transfer to the envelope components, if you don't look at the window, it's the roof which was taking the share, and then followed by the walls. So the existing masonry wall types does not have much of the variation, okay, if you look at the heat gain. So they were more or less the same. So to conclude, okay, the warm humid climate has the least diurnal variation among other variants of the tropical climate, like the hot dry or maybe your composite climate. And for a building where the surfaces are all exposed, okay, the contribution of roof is the maximum if you don't take the openings followed by walls. And it is seen that the influence of wall materials on heat gain, okay, is not very significant. This we are talking about in terms of warm humid, where the diurnal variation is quite low. But however, when it comes to a situation where you don't have a roof which is exposed, and when you have only the walls exposed, probably there can be a choice that you can make in terms of the performance when it comes to some of the masonry materials, if that is by which the walls are made. So that is the overall conclusion of the study. We hope we'll be able to do much on this and come out with some concrete results. And we sincerely hope that, okay, this will make others also to look into this and do future studies. So thank you.